Okay, so we're going to start with physics past question 2018. Are you there? Okay, Chika, are you there? Can we start?
Yes, I'm here.
Okay, so let's go with the first question. Are you there? Can you hear me? Okay, the first question says the SI unit of sound energy is what?
Said the SI unit for sound energy is hertz. Sir, I said the SI unit for sound energy is hertz.
Okay, you're back. What's wrong with your, is it your internet or what?
Yes, sir.
What was the issue? Your internet, huh?
Yes, it's turned off. It's the hotspot I'm using.
Okay.
So I said the SI number two.
Let's start with number one. Huh?
So I said the SI unit is hertz.
The SI unit is what?
Wait, I'm coming. No, wait. Hey.
Can you still hear me?
Yes, I'm here. Number one is
Okay. Number one is what?
A. Size, from what I'm seeing now, is G.
Number one is what?
For frequency, sorry.
I can't hear you very well. You said what?
Number one is going to be joules.
Yeah. You said it was A before, but
Yes, but I just saw that it's not frequency.
okay, you then saw what I have on my screen, but
Yes.
okay, so whenever you see the word energy, that's what they use in confusing you, because when you see sound, you probably think about head. You understand?
Yes.
Uh-huh. So when you see sound, you'll be thinking about sound wave. But once you hear the word energy, it's talking about energy, sound energy. Whenever it's energy, then the unit is always joules, isn't it?
Yes, sir.
Uh-huh. So when you hear frequency, the SI unit for frequency when you hear frequency, that's the SI unit for frequency is hertz. When you hear about
Yes,
luminous
sir.
intensity, the SI unit is candela. You understand? Then when you talk
Yes, sir.
about relative loudness and sound, you talk about decibel. But once it's energy, that word energy, then it is joule.
Joules.
Are you clear
Okay,
on
sir.
that?
Yes,
So
sir.
let's move to the next question.
Number two.
Okay.
The general definition of elastic modulus is A. Tensile stress over strain. Is that correct?
Read out all the options, okay?
A. Stress over strain. B. Strain over stress. C.
Yeah.
Stress times strain.
Yeah.
D. Square root of
Okay.
stress times strain.
Okay. The question says the general definition of elastic modulus is what? So is this stress over strain, which is actually what it is, or is it strain over stress? That's the opposite or the inverse of the first one, or is it stress times strain, or is it the sort of stress over strain? So Hooke's law, for you to understand this, you need to understand Hooke's law, which is the concept behind this. Hooke's law states that stress is proportional to strain, provided elastic limit is not exceeded. That's Hooke's law. So you're most likely going to be asked in your Waec or your Jamb to make the statement of the Hooke's law. So it's good you understand that Hooke's law simply states that stress is proportional to strain. So the amount of stress you apply is proportional to the strain that you're going to have, provided that the elastic limit is not exceeded. And this is the representation. Stress is of proportionality, known as Young modulus of elasticity. You can now have that that Young modulus is equal to stress over strain, which is the elastic modulus as well. And that makes option A the answer. Are you clear on that? Good. Another way of stating stress over strain, you know that stress is equal to force over is equal to the increment over the normal length. So take note of this because we could have this question to come up in calculation form. So let's move to the next one.
Number three is a diagram.
Okay.
It said the diagram above illustrates a simple barometer which distance measures the atmospheric pressure. A PQ, B QR, CRS, D QS.
So which option?
So I chose A, PQ.
Okay, it says the diagram illustrates a simple barometer which distance measures the atmospheric pressure. So is it QQ? Is it QR? Is it RS? Is it QS?
So I don't know how they
Okay,
got the
so
answer.
okay. This is PQ. The one you say you
I can't
chose.
see the
PQ is
diagram.
just okay, you can see it.
So I can see it.
Chika, can you see the diagram?
Okay.
Yes, sir.
I mean on my own screen, not your own screen. Can you see the diagram on my own screen?
Yes.
What of Emmanuel? So why are you not seeing the diagram? Chika, I hope you're seeing it on my own screen, not your own screen. Oh.
Yes, I'm seeing it.
Okay.
Yeah.
So this is an illustration of what it is. Can you see the second diagram that I drew with my pen?
Yes, I can see it.
Okay. So when you're measuring, this is hedge. Can you see hedge?
Yes, okay, don't worry.
Can you see
Yes, I
this
can
hedge?
see it.
This hedge measures the pressure. You understand? This peak is
Yes.
actually the vacuum. So H is actually what is measuring the pressure. And that's why when you say atmospheric pressure is 760 millimeter mercury, that's this H. So it's actually the distance between this point of vacuum to where the liquid level is. And that is our QR. And that's why option B is the answer. It cannot be PQ or RS. Is that clear?
Yes, sir.
You understand it now?
But sir, how come
Emmanuel,
the
can you?
type is now referring to the QR?
Yes, they did not explain it that way there. But if you know about the barometer, this is actually how it is. You understand? So for you to understand this diagram, you need to know about the simple barometer diagram. Use the measuring atmospheric pressure, okay?
Okay, sir.
Emmanuel, can you see the screen now and the diagram? Emmanuel.
Yes, I can see the distance. I can see the diagram now.
Hello. Hello, sir. Hello, sir. Hello, sir. Uh, so, hi everyone.